Now, coming to the predictability, so we saw that ENSO predictability is quite strong. In this plot, particularly, we saw that 3 month lead time, 6 month lead time, 9 month lead time, and 12 months lead time. So, as you go beyond 6 month lead time, we see that tropical Pacific and tropical, especially tropical Pacific, has good correlation or good skills. Correlation means skill here. So, red means good correlation between model prediction and observation. So, the skill of the model is pretty high for the tropical Pacific, but it is not so high for the tropical Indian Ocean. So, beyond 6 months lead time, the predictability of the Indian Ocean dipole is not so high, and that is happening because of the cycle in the basin. We have two barriers, spring barrier as well as winter barrier in the Indian Ocean. So, the predictability is pretty high from January to 6 months ahead, above 0.6 in this case, but as you go beyond that, the scale reduces. So, that is why the scale for the IOD is good 1 to 2 seasons ahead, 3 to 6 months ahead, not so good beyond that. We also try to understand if the predictability of IOD is influenced by ENSO, and if ENSO also influenced by the predictability of IOD. The right side plot here is showing you the experiment when we suppressed ENSO, no ENSO experiment. You can see that the predictability IOD was not so much dependent. The black line is observations and the green lines are different lead time predictions, and you can see they are going together very well. So, in some sense ENSO is not influencing so much the predictability of IOD, at least in this model, syntax F model that we are using. So, ENSO variability is not so much influencing the IOD predictability. So, in that sense we can't say that IOD predictability will improve if we improve ENSO predictability. Nevertheless, we know that when ENSO happens, the Somali region gets warmer, and in that way it can influence the Indian Ocean dipole intensity to some extent. However, if we decouple the Indian Ocean, so in that sense we have no IOD in the predictions, we find that the ENSO predictability, especially the early part of the ENSO predictability, is highly affected. So, the predictions were missing the observations. The green line is first predictions, the red line next one, and the blue line at the peak stage. So, the mature stage predictions are not so much affected by not having IOD in the predictions, but the early stage, the initiation stage is very much affected by not having IOD in the model. So, predictability of ENSO, particularly early part of the ENSO, is strongly influenced by whether we are having IOD or no IOD. So, now no IOD will have less predictability for the ENSO, for the early part of the ENSO. Now, this is some of the examples of the predictions given by the syntax model. This is the 2019 IOD predicted from April 2019 for the September, October, November sea surface temperature and rainfall prediction coming from the 2019 April. So, you can see that model was very well predicting. There was no El Nino, very weak signal in the SST, no El Nino, but strong dipole, and both in rainfall, very dry condition over Indonesia, wet condition over Africa and Sri Lanka and India, and upwelling and cold temperature of Java and Sumatra, and that was very well observed in 2019. If you remember, we had a lot of forest fire and drought over Indonesia during 2019, when we did not have El Nino, we only had positive Indian Ocean dipole. That confirms our hypothesis that the Indian Ocean dipole itself can develop by itself and through internal dynamics, and its influence will be very strong whether we have ENSO or not. Now, we have been doing the predictions since 2001, but the predictions were available from 2005. If you go to our website, you can get these monthly updates. Every month we update. You can get the January updates now, January 2026 updates now, and using this website you can check the Indian Ocean dipole, ENSO, SST, and rainfall predictions for 1 to 12 months lead time. The Indian Ocean dipole prediction using SYNTEX-SAFE is one thing, but there are several other techniques we have tried to use, because we know that the skill of IOD prediction in SYNTEX-SAFE is not so good beyond 4 or 5 months. So that's why we are trying to improve on that by using some of the machine learning and deep learning techniques. In this study, Ratnam et al. Found that ANN, the artificial neural network, this is the machine learning technique, not the deep learning, it's just artificial neural network, can predict the IOD better than any of the North American model. NMME is the model ensemble, multi-model ensemble of the USA and Canada. So, you can see that these are the blue line here is the ANN from February, orange line is ANN from March, and the pink line from purple line from April, and the other are from NMME or persistence. So, these 3 lines you can see that the predictability is much higher compared to the dynamical model from the NMME ensemble members. This is the correlation scale, which is close to 0.6 for the ANN model, 6 to 7 months ahead, much better than the dynamical models. And this is the RMSE and the root mean square errors, which is also better than the NM. If the root mean square error is lower, it is better. So, you can see these 3 models, which is coming from ANNE, are better than the NMME, North American multi-model models, multi-model ensemble models. So, in some sense, the ANN was doing better in predicting, and so in predicting IOD compared to some of the dynamical models. So, this gives us hope that in addition to dynamical model, we can use AI machine learning to predict Indian Ocean dipole, and combining the dynamical model predictions with statistical model predictions like AI machine learning, we can develop better prediction system for Indian Ocean dipole. There is another paper, not from our group, Liu et al. 2021, who tried to use a deep learning technique. ANN is a very low level of neural network. Deep learning technique, they are much deeper level. In this case, they are using CNN, convolutional neural network. I showed you for ENSO, we did that for the NINO3 prediction, and the skills are better for 12 to 18 months lead time. In this case, they are predicting September, October, November Indian Ocean dipole index using CNN, and you can see that black line is CNN. Skill is pretty high, 4 months to 5 months lead time, and continue that up to 7 months lead time. So, above 0.5 correlation skill. If you compare that with NNMEs and different component or different model in NMME, these are the model CSM, CanCM, GFDL, GameNemo. These are the model included in NMME ensemble average. So, blue is the ensemble average and other lines are the individual models. You can see that black line is far above them beyond 3 months lead time. So, 3 to 7 months lead time, the CNN model was doing far better than any of the dynamical models. So, this gives us hope that we can improve the Indian Ocean dipole predictions by using ANN, CNN and other AI deep learning techniques. So, talking of AI machine learning, we know that we can use these techniques together with dynamical model to produce what we call the digital twins. So, we have the real world, we have the virtual world, the model world, either statistical or dynamical. And by combining observation coming from the real world, simulation results, prediction results coming from the model world, we can combine them, then use the AI technique to develop a different information system. Predicting something is one thing, but developing information out of that is another thing. So, we need AI both for predictions as well as creating information that will be useful for the society. So, by combining observation, model, AI, we plan to develop some kind of digital twins with smart interfaces, which can be used by both specialist researchers as well as general public for various societal applications. This is one of the first version of that kind of interface we are developing at Jamstack. So, these kind of 2-dimensional, eventual idea is to produce a 4-dimensional virtual earth, 3-dimension x, y, z and also time. And also on top of that we will add some of the analysis tools, statistical dynamical analysis tools that can help general public to take decisions based on their own needs. This is just the first version of the 2-dimensional virtual earth, taking all the predictions in it, observation, reanalysis, prediction in it, and providing an interface. You can go in, click and either see the simulations or click any point to get a time series, or go to the indices. There are several indices, NINO3 index, dipole mode index, monsoon index. Those can be seen, Modoki index. Those can be seen and also downloaded. These indices can be downloaded as text file. We also have several ocean models providing very high resolution simulations all over for the globe. So, the idea is like, okay, we have the digital twins and we have various tools, then that can provide a smart interactive interface independent of which kind of media you are using, laptop, smartphone, whatever. Then this kind of interface can provide you real time information as well as predictions and various informations that can be applied for early warning and for the needs of stakeholders. So, this is the idea, like the farmers, they do not know whether it will be flood or drought, flood, extreme events, whether it is ENSO, IOD, he does not understand how to react to different predictions. So, digital twin will give him direct information. Okay, this is the situation happening now. You should go and optimize your water use, fertilize, put the pesticide or harvest, and depending on different state of the weather and climate in that region. In some sense, it will also help reducing carbon dioxide by reducing emissions from inefficient inputs, optimizing soil management, and enhanced soil organic carbon sequestration. Future projections of IOD,